Okay, so now let's actually start. I need some time to get my thoughts together, and I got a bunch of questions after lecture. All right, so let's do this. Cross-site request forgery. One of the acronyms I always get wrong. XSRF. For whatever reason, we read X's. X's you'll see in a lot of acronyms in web, and specifically web security. X we read as cross, so instead of CSRF, we do XSRF. I don't know why. It's just one of them things. We use X's instead of C's for cross. Sometimes you will see these with C's, but cross-site request forgery. That's what we want to talk about today. And this is the last topic for the homework. This is your application objective 2. Last time we did application objective 3. We've already done application objective 1 and learning objectives 1 and 2. This is the last piece for the homework. And Friday, we're not going to talk about homework stuff at all. We're just going to mess around with browser extensions, which we might start today, depending on where we end up going after the slides. I got a few things I want to do. We'll see how long it all takes. So cross-site request forgery. We have this vulnerability now where we have a form on our front end that allows you to send HTTP requests. Right now, the form takes a comment and an image, and you can submit that comment and image to the site, and then that comment and image is posted to the site. Not too much of a threat right now on our specific site for the homework, but as we start building forms that do things on a user's behalf, we have a vulnerability that we have to be concerned with, this cross-site request forgery. So the concern is when you have a form on a site where you need to be authenticated. Say we have a chat app. Say we have the same app that we're building for the homework, but we already did homework 4 and we have authentication. And posts are made in a user's name. Instead of just having your image and comment just posted, just out there and whatever, it has your name next to it. And some malicious person says, you know what, I want to try to make a post on their behalf. It'll have their name next to it, have your name next to it, but it'll be some ridiculously inappropriate, image or whatever. And maybe more concerning, maybe less concerning, depending on how you feel and how much money you have. What if there's a form on your bank account for online banking that will transfer money to other bank accounts, right? What if somebody could submit to that form on your behalf and steal all your money? We need to be protected against this, or else people are going to abuse that. So what is this? This cross-site request forgery is when somebody makes a request for somebody else, usually without their knowledge. So the way this works is you have a form that just submits a post request, right? But you don't have to use that form to submit a post request. You don't have to use the form. And we have a way to send requests in a lot of different ways without using the form. One, we could use Postman. We can simulate post requests. We've did it for homework 1. We just simulated those requests without the form, without the front end, without HTML at all. We could do the same thing with like a Python script. We can write Python code or any language. Doesn't have to be Python. Python's the easiest way to do it, though. Import requests and just do it. But you can send off HTTP requests using code. You can write your own code that, like we have TCP server code. You could write TCP client code and fire off any bytes that you want to any web server on the planet. You can write your own HTTP requests by hand, send whatever you want to any server. Like you have full control over this. Those uploads don't have to come from that form. And further, your server, if it gets a post request, it doesn't know whether that request came from that form or not. You just see post request for form upload or whatever the path is, and you check the MIME type, you get the boundary, you start parsing your multi-part body. Nowhere in there do you say, oh, gee, did this come from my front end, from my HTML code? And even if you do have some checks in there, they're likely able to be spoofed by a sophisticated attacker. They're going to make the request look like it came from your form, and you're not going to know whether it actually came from your form or not. So you trick somebody into clicking your shady link. They go to your website. You got some JavaScript in there with some AJAX, because we know another way to make HTTP requests with AJAX. They got some AJAX on that site that makes a request to that form, creates the post request, has transfer all the money to attacker's bank account. In that request, your bank says, oh, dude wants to transfer money. Okay, let me transfer it for them. And then all of a sudden your bank account's cleaned out. We need to protect against this one. Oh, well, I got ahead of my slides already. And you see this in spam email all the time. You get a spam email, there's some shady link. If you know, what's the danger? I'm going to click on this and see some bad stuff that I don't want to see, or see some ads or whatever. Well, no, they could be more malicious than that. They'll have some JavaScript that makes some AJAX calls on your behalf, send them to any site that has this vulnerability, and just hope you have an account on that site and that you're logged in, and that site's going to take that request and say, oh, yeah, this person wants to do, whatever. Let's do that thing, because it's clearly a request from that user. We're going to honor that request. Okay, so how do we prevent against this? How do we prevent against this attack? CORS is the answer. We're luckily, automatically protected against this, which is great. So CORS, cross-origin resource sharing. So this is a policy enforced by your browser, importantly, that will protect us against these cross-origin requests. So the fundamental part of a cross-site request forgery is that it's making a request across sites. That's the key part of it. So if they want to attack you, I guess, at CSE312.com, bad example because you don't have accounts or private information or anything to attack on there. But if they want to attack that, they're going to get you to go to attacksite.com, and then from attacksite.com make a request to CSE312.com. So it's a cross-site request. You have to have an absolute path built into that AJAX request. You can't just do /form path. You have to do http://CSE312.com/form path or whatever. So you have to have the absolute path and send a cross-origin request. That means the origin making the request did not come from the same origin that, oh man, that sentence. The origin of the original request is not going to the same origin. It's cross-site. I'm getting lost in my words there. It's a cross-site request. So the origins are different. Where your origin, like for your homework, is localhost or 0000, like that's your origin. And if you look at your headers when the browser sends a request, it'll say, is it origin? I feel like it was, I feel like it's a different header. We'll see when we go to the demos. We'll take a look. It'll say origin. This is where the host of where this request originated from. So if that origin doesn't match the server that's the request is going to, that is a cross-origin request. So we have some policy for this, the CORS policy that the browser is going to enforce. A lot of times, if it's for example, if it's a GET request, it's just going to say, yeah, whatever. You've done this before. I can pretty confidently say probably almost everybody in this room has created a cross-origin request. You find an image somewhere on the internet. You copy the link to the image. You go to your HTML and you say img src equals paste. That's going to create a cross-origin request from wherever you're hosting your code over to that other origin with that image, and then get that image and put it on your website. That's a cross-origin request, but it's allowed because it's a GET request. You can't do much damage with a GET request. You can if there's a query string on it. You could do damage with a GET request if the other site is set up in a wonky way, honestly. It's potentially possible. But usually you can't do any damage with I'll say much damage with a GET request. So those are usually allowed. But whenever you have and JavaScript libraries. JavaScript libraries, you probably have sites, if you've done any HTML before, and you import Bootstrap. You import that by giving the absolute path. You make a cross-origin request to get the CSS in JavaScript for Bootstrap. jQuery, same thing. You make that cross-site request to get those libraries. You can, when you're actually hosting your site, you'll usually download those libraries and host them yourself. But when you're just testing stuff, you'll do the cross-origin request and get them from some CDN. Very common to do. So if you've done any HTML at all, you've probably made cross-origin requests before. So a lot of times it's allowed. But once it's not a GET request, once it's a POST request or any request that's requiring some processing from the server, something that can do some damage, then it's going to be subject to the CORS policy, and it'll be automatically blocked. So those requests that aren't GET requests, a lot of it is just straight up blocked. You can allow, please don't do this, you can allow cross-origin requests. So in your server code, if you want to say, look, I have this path, it's a POST request, and I want to allow other hosts to be able to hit this endpoint, you can do this. You can say allow control access origin star. If you put this header in your response, then that will allow all cross-origin requests to hit that endpoint. I shouldn't say don't do that, but don't do this to fix bugs. I've seen people do this to fix bugs. I'll admit that I fixed a bug like that before. I just added this header to be able to do that. I updated that code. But don't do this to fix a bug. If you do want to allow cross-origin requests, like for APIs, it's common to allow cross-origin requests because that's the whole point of an API. You'll do cross-origin, allow origin star just being the wildcard for any origin, or you could put a list of origins that you'll allow. Yep.
If this is enforced by the browser, how does that actually protect the server?
It doesn't. It doesn't. So, and that's very important. It's a very important point. This is enforced by the browser. We have zero control over the browser. So how confident are you that the browser is going to protect against that? One thing, we do have some assurance that we're getting some protection here because we're vulnerable to Postman and somebody writing a script and everything. But the Postman request or the script, it has to be ran by the person being attacked. It doesn't help that the attacker can send those requests because the attacker can always just go to your site and type whatever they want in the forms. So the attacker has to get the victim, I'll say, to run that script or run that Postman, which is pretty difficult to do. That's why the attacks are usually click this shady link. That link has JavaScript sending an AJAX request. That's going to be the common way to attack someone because it's easy to get somebody to click a link. Very hard to say, okay, go to Postman and do all this stuff. So we do have some confidence in that. The issue is our users that are using very old, out-of-date browsers that don't implement CORS properly. That's going to be the big concern. So we're not too confident in the browser. So this overrides, the browser will see this header and say, oh, yeah, I am allowed to do this. And then it'll make that request. But otherwise, the browser is going to block the user from making the requests. The user, in this example, being the attack JavaScript code, the browser is going to say, whoa, you're trying to make a cross-origin request? Nah, let's not do that. And the user probably doesn't even know that they were trying to make a cross-origin request. So, it's my very next slide, actually. So since CORS is enforced by the browser, how confident are we that that's going to be enforced? Lots of things can go wrong when we're trusting the front end. When should you trust the front end? Who's your user? When should you trust your users? Never, ever, ever. Never trust your users. So users do funny things. One, they might be running out-of-date browsers, which isn't really a funny thing, but some people are still running like. I think this is still true. There's got to be some people out there running Windows 98 still, like really old Internet Explorer versions, and you might have those users using your site. Do you want to just say, well, those users are going to get attacked? Like it's tempting. It is kind of a debate in web development of what should we do with these users. It takes a lot of effort to make sure everything's compliant with like IE6 or IE8 or something. Do you still support those old browsers? Do you just say, we're comfortable losing those users? It's debatable. It's debatable. I think you should do what you can to help them out. But old browsers might not have cores implemented properly, or maybe they had a security bug that they had to patch, and that user just didn't download the patch. Doesn't have the patch, doesn't have the most up-to-date browser, and it isn't working. Which, yeah, that's, you know what? We got time, I guess. I actually had this bug in not with cores or unrelated to this, but with my auto playing the music app, I was running into a bug. You probably experienced it the first few lectures that I had it running. I was trying to get it to play, and it just wouldn't play. And Spotify was just getting in this weird state where the play button turned into the pause button as though music were playing, but no music was playing. It wasn't even trying to pretend to play music, and it was just the pause button. And I looked up forums and tried to find out what was going on. It took a while, at least an hour of digging. And this one forum said, "Oh yeah, from 2018, said, oh yeah, you got to update your browser because the Spotify web app doesn't play nice with older browsers." I'm like, my browser, yeah, I didn't update, but like a month ago, and it's 2023. I don't think that's the problem. But just to humor them, updated my browser, and it worked. It fixed the bug. So even with whatever they updated in the Spotify web app, which sucks, by the way, I'm so frustrated with it. Whatever they updated within that past month actually didn't work on Opera that was 1 month older. And I tested this in Chrome as well. Didn't work 1 month older of a browser. I had to update, and it finally worked in that. I also had other bugs. My ultimate solution was actually to use Firefox because I think it's just not playing well with Chromium. But anyway, out-of-date browsers in some cases, hopefully not in cores at all, but in some cases, even a month old, you can run into a bug, which is just something else. I've seen students do this even. Some people install plugins that disable cores. This is when I've seen it, it's been developers where they're trying to write a web app and something doesn't work, and they find some forum somewhere and just blindly click through the solution, and they install a web extension that disables cores on their browser. These extensions exist. You can go download them. Please don't. You'll open yourself up to all kinds of attacks. But some people install these extensions that disable cores. I guess it would have to be a plugin, wouldn't it? Plugins that disable cores. They're vulnerable to cores. They're vulnerable to cores attacks. So we can't trust the browser. We can't trust our users. Some of our users don't want to be safe out there, and they will actually do this, which doesn't fix your bug in your app. Once you go to deploy, you're not going to deploy and say, install this plugin that disables cores. Please don't. But it's not 100% is the point. Trusting the browser is a bad idea. That's equivalent to trusting your users. So let's get some server-side protection. That's what we want in this course, server-side stuff. We're going to be 100% protected because we're going to implement this server-side. I don't care what browser you're using. I don't care if you're not even using a browser. If you're using curl, it's still going to work because we're going to implement it on the server side. So what we'll do is create cross-site request forgery tokens, XSRF tokens. And this is your application objective 2, is to use these tokens. So whenever a user requests your page, your home page, or in general, any page containing any form that you need protected, that you want protected, you're going to generate a cross-site request forgery token, a randomly generated token, and embed that into the form. And then you're going to go to your database, you're going to save that token, and say, this is a valid XSRF token that I issued and gave to one of my legitimate users. Well, you don't really know it's legitimate, and we'll talk about that in a second. But this is a token that I issued. It's randomly generated and long enough that somebody can't just guess what the token is. And we're going to give that to a user, embed it in the form, save it for later, store it in your database. that you issued this token. And now when you get a request for that form submission, you're going to get the request. The request is going to have that embedded token, which will be invisible to the users, by the way, to legitimate users. You use these tokens on sites all the time. You just don't see them. They should be invisible to users. You'll get that token. You'll get the form request, and you'll check the token and say, is this a valid token that I issued? You'll go to your database and say, is this a valid token? And if it is, you respect the request and you process the form submission. If it's not a valid token that you issued, you ignore that form request, or rather, you don't ignore it, but you respond with a 403 forbidden. You say, you're not allowed to do that. Something you did was messed up because you didn't have one of my tokens that I issued. So this is how we can protect against cross-site attacks, even if the browser is allowing them. Is the attacker spoofing your IP address? Good question. What of your information are they using to pretend to be you? So they're not really spoofing your IP address. When you visit their page, you're downloading their JavaScript code, running their JavaScript code, and then the request actually comes from your machine, from your actual IP address. So there's no spoofing involved. The request is just actually coming from you because you're running their JavaScript. That's the scary part of it. There's not really a good way to tell that it wasn't a legitimate request that you wanted to send. Because you might go to a site, all the time you go to a site that runs JavaScript and makes requests on your behalf that you want to send. So with the attack site, it's coming from you. It looks legitimate. But if it's a cross-origin attack, or if it's a cross-origin request, rather, it's going to be blocked in most cases, if everything's set up properly. And if not, hopefully we got some cross-site request forgery tokens or something else equivalent to be able to protect against it. Yeah.
Is there some type of like secondary check that like the
No. Yes, but no. So excellent question. So what you build in homework 2 isn't actually going to be completely secure for that exact reason. We don't know that the token that we actually issued to the person sending the request. We have no way to verify that. When we get to homework 4, we'll add to this and link the token to a user account, and then make sure that the request came from the same user that we issued the token to. So the problem with the setup that we have right now is that the attacker can go to our site, or not even go to our site, but just send a request to our site, get the response, grab the token, and then give that token to their attack script, and then use that at least as a one-time attack for a user. And they can automate the whole thing to get as many tokens as they want. But they can get valid tokens, send them, put them in their attack script, and have requests with valid tokens, and actually still pull off a successful attack. So our homework 2 code isn't 100% there yet. We will revisit this in homework 4 when we have authentication and profiles and all that stuff. Then we'll be absolutely secure. I think I was... Yeah, no answer. I feel like there was something else I was saying. I think I answered that question. They don't have to spoof your IP. All right. So I believe I put in the homework doc a specific length, because I always get the question. These tokens should be randomly generated. They should be fairly long. They should be next to impossible to guess if you're just guessing the things. I think I put a length requirement just because I kept getting the question of how long to make it. I don't know, just make it really long. Make it 20 characters. I don't know. But understandably, there's concern, like, what if I don't have it long enough and then I don't get credit? I don't know, make it 20. If you make it 20 characters, you'll be fine. General rule of thumb, use the same rules as your passwords. As long as it's 8 characters, you're going to get credit. But 8 characters is pretty standard minimum password length, which isn't, we'll talk about this later in the semester, isn't secure. Use more than 8 characters if you want to be secure. If you don't care, I don't know. I have some 8-character passwords for sites that I don't really care about. But if you care about your security for like your bank account, use more than 8 characters is my recommendation. So generate these tokens. Oh, and you can use the secrets library. I get that question a lot. In Python, there's a secrets library. Import secrets. Use secrets to generate your random tokens. That's perfectly fine. Or you can write code to generate your tokens manually. Either way is fine. I think it's more fun to generate them manually, but it's more secure to use secrets to generate your tokens. So you're going to generate a random token. You're going to embed it in your page, store it for later. Did I already read? Do I have the same page toy? No, I just accidentally clicked the button. So you're going to generate this token. You're going to embed it in your form. And this can be a hidden input. This is the recommended way to do it. I don't believe I put in the testing procedures that it has to be a hidden field, but it should be. You don't want your end users seeing these cross-site request forgery tokens. The end user doesn't have to care that this exists at all. You've never had to care. You probably never cared your whole life until today, and you're like, oh, what are these? But you can put it as a hidden input. If you just put hidden here, this is an attribute with no value. It's just a key. This is the same as saying hidden equals empty string. I believe it's the same exact thing as that. But this will be a hidden field with a specific value and then a name. Make sure you note the name that you give it, because you're going to see that same name on the other side, on your server side. Because this is going to send a request with that name in your multi-part form, on your multi-part request, and then the value is going to be your token. So you'll have a third part in your multi-part form for your cross-site request forgery token. You have to parse this, check if this is a valid token that you issued. For the purposes, again, homework 2, it's not going to be 100% secure, protected against cross-site attacks. But if you get the request for your homework 2, read this token and check if it is a valid token that you've issued. If it is a valid token that you've issued, then respect the request, treat it as normally. If it's not a valid token that you issued, then send the 403 and say you're not allowed to do that. There are ways we could, there are things we could brainstorm. We can try to talk about some. So I'll get in before one of these. Why don't we attach that to an IP address? We have a TCP connection. We have the IP address or the port number. They might create another TCP connection with a different port, but why not use the IP address and associate that token with the IP address? The problem is that IP address can change quite often. For example, if you open up, you go to a website and you start a form during this class, which I know you're all paying attention, you wouldn't do anything else during lecture, right? But you start filling out a form, class ends, you go to your next class, you open it up, and you finish that form. Well, as you're moving around campus, your IP address is constantly changing. As you're connecting to different access points, you're going to get issued different IP addresses as you're wandering around the network, as you're switching around the Wi-Fi infrastructure. So once your IP address changes, if that token is associated with your IP address, well, that's not your IP address anymore. You submit the form, you get a 403 forbidden, and you swear and curse as you have to fill out that entire form again, which, depending on how long it was, might be really frustrating. So not something we want to do. We don't want to associate anything with IP address. We don't want to use IP address to identify people. That's not consistent enough. And even worse, what if you go all the way home? Like, we could say, well, it's still a UB IP address. What if you go home and then open up your laptop and finish filling out that form? You have a completely different IP address from a different service provider. It's going to be very different. So users do not have consistent IP addresses. We can't use that to identify them. Otherwise, that would be a good strategy. It's not going to work for us in this case, or in most cases. We don't use IP addresses to. We might track that information for other purposes, but not for identification purposes. It just isn't useful. At least not when we need 100% accuracy. It's not useful. Oh, I got no more slides. Okay, so let's do some demos. Don't want to break an image. Let's Oh, my brain can't do demos right now. Hold on. Terminal. There we go. Let's start Docker. No, Docker's already started for once. All right. So let's fire up our app. Go to localhost. I cleaned out all my Docker stuff, so I have to re-download the images. But we're going to fire up our server and refresh. We'll see this server. We've seen this quite a bit. We have this whole thing. Let's pick on this form here, Hartloff. Hello. Inspect element. Network. Oops. Let's see if we can attack me. So we have this. We have this request going to this insecure chat path. Oops. Do I want to create a whole multi? Oh, no, I can do this. Let's just copy this, actually. So let's create an attack site. We'll go into VS Code, so it's completely different. Let's use this example.html that we've used before. And I want to create actually, I can just use the same thing right here. And I want to create an attack site that's going to make a submission to that form. So in my path, I'm going to put my absolute path of the site that I want to attack. In this case, it's just localhost, but my localhost /insecure chat. And I'm going to set up my form in the same way. Instead of doing the AJAX, I'm not going to build a multi-part form using AJAX. Actually, I could. I just showed you how to do that last lecture. We could do that. But for now, let's do it with a form. I'm going to have my multi-part form data, and I'm going to make sure my names match the names in my other site. So if I'm an attacker, I don't have access to the source code, so let's just do this from the browser, whatever information the attacker would have access to. They're going to look at this form, and they're going to just honestly just cut and paste this. But let me get name, username. So name, username, name, message. These are both text. They're both text types, text fields. The IDs, the labels, none of that's going to be sent to the server, so I don't have to update that. And I think that's it. Submit. ID doesn't have to match. Method, let's make sure our method is post. Our encoding type is multi-part form data. And we have a form that's going to mimic that form on this page, on the other page. So let's open up this HTML. Now this is obviously would be hosted at the attacker's site, but we can just open this for now at least. Reveal in Finder. Let's just open it. And let's, from a different site, forgery, I'm missing my S. I always get this acronym wrong. I have to spell it out every time. You've been cross-site request forgeried. We're going to submit. We're actually going to see the page because the page redirects to what I've seen, the HTTP request returns a redirect to this page, the way the server's set up. So even though the form came from a different site, it's still going to redirect me to this site. And then I can see my attack right here. We've been attacked. It did send from one site to another. We got the page reload, but we could do this without the page reload. Let's do that. I don't think it'll take too long. action, we want on submit equals f of this. Sure, let's do that. Return false. So we're going to call some JavaScript function f. How the hell are you going to say I can't return? Return statement can only be used within a function body? I don't believe you. Equal greater than? Do I have to wrap this all in a function? Is that what you're saying? I don't think I have to do that though. That didn't even compile. Wait, what the? This is embarrassing, but I have to look at my slides. On submit, return false. Yeah, no, I had it. I'm going to be stubborn about this. We're going to get this. It might, let me take a shot in the dark. It might be mad just because my function doesn't exist. So let's write the function first, since we're going to have to do that anyway. Function, bless you. Function f. Okay. Yeah, I'm going to go with that one. That's just a shadow error. It might not be a real error. So let's get this new form data of element. And you can do this, by the way. This is a reference to the HTML element. So I'm going to pass this, which is the form, instead of like I showed last time where I was getting the form by ID. I just didn't feel like doing that. So let's do it this way. Form data element const form data equals, get my new XML HTTP request, because it can't be called AJAX request, that'd be too easy. Const request equals mu request that send form data, request that open post HTTP : / Is it still in my clipboard? It is. Insecure chat, form data. Yeah, let's roll with that. Go over here. Attacker. I'll be surprised if this works, but let's. If not, I'll get to show you how to debug stuff. Attack. Oh, I guess I don't get to show you debugging stuff. So this is going to run on the attack site. Somebody fills out this form. Now we don't have the refresh. There's no, it just looks like it didn't work to the end user. And like, oh man, this form's busted. And you go to some different site. Meanwhile, that just made a request to your bank site, your your web banking app, and just drained your whole bank account. Looks like it didn't do anything though. Even scarier than that is let's take this a step further. So let's pre-populate this form. Value equals U. Value equals send me all your money. And something we talked about last time, which we didn't do. Actually, I am going to change this now that I think about it. Let's do another function here, which isn't going to take any parameters, which will find that form by ID. This is a weird way of setting it up, but just kind of the way it unfolded naturally. Let's give this form an ID. ID equals the form. And I can't type. We're going to oh my goodness. Document dot get element by ID, the form, const element, and then we'll just call our other function flm. So this function isn't going to require somebody to click submit on the form. It's just going to grab whatever's in that form, which is preloaded with our data. Of course, you wouldn't use the form at all, but I don't feel like constructing my own multi-part requests. I want to use the form to generate my multi-part requests for me. And why are you mad at that? Oh, I don't have my open brace. So we can run this. We could just say attack. And of course, the JavaScript should be in its separate file. Just for the sake of time, I'm taking a lot of shortcuts here. And then we refresh this. Then we refresh this. Oh, that one didn't do it for me. Let's... Oh. I suspect that just wasn't loaded in yet. Now, when you visit this page, you click that shady link in your email, you don't see anything. And this form can even be hidden. We can just hide this whole form. Why don't we do that? That'd be the easier way to do it. Never tried to hide a whole form, so I'm not sure if that works, but let's try it. Okay. You go to the site, you see nothing, or whatever the attacker wants you to see. You don't have to see any of the attack stuff. But that request was just sent. It was fired off, and you're none the wiser. You just click a link, everything looks fine, but you were attacked. So that AJAX request that is a cross-site request forgery attack just made a request on my behalf when I visited this page and sent that attack over here. So if this site, which it's not protected right now against cross-site request forgery, it's getting those cross-site request attacks and just respecting them as regular attacks. And let's go a step further. So we talked about polling last time. I didn't get a chance to do a demo with polling. So let's, instead of just attacking once when the page loads, I should explain what just happened there. I put my script up here. I called attack right here. The problem with that, actually, let's go back to that and talk about it because this is pretty important. When I call attack right here, what's most likely happening, we'll check and verify in a second, but let me explain it first, is what's happening is this script is running when the head of the HTML is being rendered. We get to this attack, the function is defined, it calls the other function and everything, but when it gets right here, guess what hasn't happened yet? The body hasn't loaded. This element doesn't exist because it hasn't loaded yet. It hasn't loaded the body, it's only loading the head elements. So the order in which things load is important on the front end. That's why a lot of times you'll see your JavaScript at the end of the page, at the end of the body, because then you know everything else is loaded first, and then the JavaScript will run. Or you can do what I did here, is do body.onload. That's going to say after the body is completely done loading, then call this JavaScript, which is a guarantee way to make sure that everything's loaded in the body before calling your JavaScript. So if we change our code to this and go to the browser, Go to inspect element. Go to the console. We should see an error in there. Error failed, not type form element, HTTP requests. No. We actually got a course thing. Cool. But yeah, parameter type 1, parameter 1 is not of type HTML form. That's going to be because what it actually was, which if you didn't know, every browser has a debugger in it. We can debug JavaScript. I'm going to set a breakpoint there, then refresh. What that value actually is going to be is undefined. Oh, it actually was null. Usually it's undefined, but it was null in this case. Because we got an element by ID, there was nothing there, nothing to do, because that element wasn't loaded at the time when we were trying to get it by ID. So we got nothing, and we can see that in our debugger. Polling. Set interval. Attack. We don't want to call the function. We just want to pass the function, so no parentheses. And let's attack every second. Okay. Well, let's do more debugging. Set interval is not defined. Is it a capital I? How to make that mistake? We're actually getting CORS errors. That's neat, but it's still sending the request. The browser kind of knows what it's doing, but not quite well enough. It shouldn't, well, yeah, it is. It's cross-origin because I opened this